Good day, learners. Welcome to our physical sciences lesson. My name is Amenim Kize. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. Okay, learners, grade 10 to 12. I think this topic is very, very important for all of us. Right, today, learners, we are going to focus on knowledge area, which is mechanics. And then under mechanics, we are going to focus on Newton's laws and application. Right, according to your examination guidelines, this is what actually we need to cover under Newton's laws. One, we are supposed to be able to actually state Newton's first law of motion, right? As it is from the examination guideline, which states that a body will remain in its state of rest or motion at a constant velocity unless a non-zero net resultant force acts on it. And then also need to define inertia, right, as the resistance of an object to any change in its state of what? Of motion, right? Then the mass of the object is quantitative or is a quantitative measure of its inertia. And then we need also to discuss, still under Newton's first law, to discuss why it is important to wear seat belts. So we have to use Newton's first law to explain that. And then again, we are also going to focus on Newton's second law, and this is how actually we need to state Newton's second law in words, as when a resultant or a net force acts on an object, the object will accelerate in the direction of the force at an acceleration that is directly proportional to what? To the force, and inversely proportional to the mass of an object, right? Then in symbols, so I give in symbols there, A being directly proportional to net force at constant mass, and then A being inversely proportional to what? To mass at constant net force, and therefore F net will be equals to what? MA. Then also draw what are free and what are body diagrams and force diagrams for objects that are in equilibrium and also for the objects that are accelerating. So this is what we need to focus on when we are dealing with what Newton's laws. And then also under Newton's second law, what apply it to a variety of equilibrium and non-equilibrium problems, including a single object that is moving in a horizontal plane without friction, or with or without friction, moving on an inclined plane with or without friction, moving in a vertical plane, for example, lifts and rockets, and then two body systems joined by a light inextensible string, both on a flat horizontal plane with or without the friction, one in a horizontal plane with or without friction, and a second hanging vertical from a string over a frictionless pulley, both on an inclined plane with or without friction, both hanging vertically from a string over a frictionless pulley, right? So that is under Newton's second law. So today we are going to focus on two Newton's laws, which is your Newton's first law and also what? Your Newton's second law. We are not going to look at Newton's third. So for today is Newton's first and also Newton's what? Second law, right? Then we are going to look at this next week, right? Your Newton's third law and also Newton's law of universal what? Gravitation, right? So Newton's first law, right? This is the main learners that came with, those four laws: Newton's first law, Newton's second law, Newton's third law, and Newton's law of universal what? Gravitation. So his name is Isaac Newton, and he was born in 1642. And then he died in 1727, right? So he's the one who formulated these what laws: your Newton's first law, your Newton's second, your Newton's third, and your Newton's law of universal what? Gravitation. So when it comes to Newton's first law, so we call it the law of inertia, right? So one, what is inertia? So let's go back to our examination guideline. So it's very, very important to know the definition of what of inertia. So please, learners, don't say, how come they want us to define inertia? How are we going to define it? According to your examination guideline, the definition is there, all right? So this is the definition of inertia. So define inertia as the resistance of an object to any change in its state of what? Of motion. Right, so this is how we have to, define what? Inertia. So learners, you can see it is there on your what? On your examination what? Guidelines. So this is it is what? The resistance of an object to any change in its state of what? Of motion. Right. So law of inertia, which is the Newton first law. Right. This is how we have to state Newton first law. According to our examination guideline, it states that an object will remain in its state of rest or motion at a constant velocity unless a non-zero net or resultant force acts on it, right? So if an object is stationary, according to Newton's first law, right, or the law of inertia, or because of its inertia, right, then that object will remain at what? At rest, okay? If an object is moving at an unchanging or constant, we call it constant when it comes to physics, right? We don't say it's unchanging, but it's constant, right? So if an object is moving at a constant velocity, so the constant velocity, that is the velocity that is not changing, all right? So that object will continue moving at what? At that constant velocity, right? So that is your Newton what? First law. If an object is at rest, it will remain at rest. It's like a book on a table, right? So that book, if it's placed there, right, so it will remain on the table, right? If an object is moving at a constant velocity, it will continue moving at a what? At a constant velocity. But when is that going to change, right? If now an object experiences what? A non-zero net force, then it's when the object will change its state of what? Of motion. So that is your Newton what? Newton first law. But when we define it, we need to make sure that we define the way it is on our examination guidelines. So it states that an object will remain in its state of rest, right, or motion at a constant velocity unless a non-zero net or resultant force acts on it. So that is our Newton what first law, which is the law of what? Of inertia. Okay, so then again, although it's not or is scarce or is really to have such situations, ne? But what we need to know, learners, is that if an object is at rest, it will remain at rest. If an object is moving at a constant velocity, it will remain moving at a constant what? Velocity, unless a non-zero net force acts on it. It's when now it will change its state of what? Of motion, right? Then again, by now we know how to state Newton's first law, right? So according to Newton's first law, right, an object that is at rest, it will remain at rest. An object that is moving at a constant velocity, it will move at a constant velocity, but unless a non-zero net force acts on it, right? So now let's look at the importance of wearing seat belts vis-a-vis what? The Newton first law, right? Okay, so one, why are we supposed to wear seat belts, right? So the reason why we are supposed to wear seat belts, right, remember each body has its own what? Inertia. Remember, if an object is at rest, that object actually wants to remain at rest, okay? But if an object is moving at a constant velocity, that object wants to continue moving at what? At a constant what? Velocity. Why? It's because of its inertia. By now we know what is inertia, all right? So now, when it comes to cars, for example, right? Let's say, for example, you are not wearing a seat belt, right? So if you are not wearing a seat belt, for example, a car, it's moving at a speed or at a velocity of what? 100 kilometers per hour. You inside that car as a driver or a passenger are also moving at that speed, all right? So if a car suddenly stops, so remember, if a car is moving at 100 kilometers per hour, you're also moving at a speed of 100 kilometers per hour. The driver himself or herself is moving at that speed, all right? So, and you want to continue moving at that speed. Even the car wants to continue moving at what? At that speed, right? Because of what? Of the inertia. So, but now, in case where now we are not wearing a seat belt, right? And maybe, for example, a driver is trying maybe to avoid an accident or something, right? If a driver, for example, is going to apply brakes, right? So if a driver applies brakes, remember those brakes are not applied on you, but they're applied on the car, right? So what is it that is going to stop? It is the car, right? Because of your inertia, you want to continue moving at a speed of 100 kilometers per hour, all right? So that is because of you are trying to resist a state of what? Of motion, all right? So if you are not wearing a seatbelt as a driver or as a passenger, what is going to happen to you? You are going to continue moving at that speed of 100 kilometers per hour, right? And remember, the car was moving at a speed of 100 kilometers per hour forward. So you'll also move at that speed of 100 kilometers per hour forward. Then if, for example, you are not wearing a seat belt, we are likely to collide with the steering wheel. If you are a driver or if you're a passenger, you're likely to collide with what? With the dashboard, right? So I think that is the main reason why we should wear seatbelt. In case of what, you know, such emergencies, we need to make sure that you wear your seatbelt. So reason being, you remember, if you are a passenger or a driver, if a car is, I'm giving you an example with a car. So if a car is moving at a speed of 150 kilometers per hour, you are also moving at that speed, right? So if a car suddenly stops, what is going to happen? Remember, the force that is applied is not applied on you, but is applied on the car. So what is going to stop? It is going to be the car. Then what will happen to the passengers? The passengers will move at a speed of 100 kilometers per hour or 150 kilometers per hour forward. So obviously, if you are not wearing a seat belt, then what is going to happen to you? You are going to have, you are going to experience what? Injuries. So that is one of the importance of wearing seat belt. Now explaining that using the law of inertia or Newton first law. Another example, I think learners have experienced this, right? So let me just give you an example. So let's say, for example, you are standing on the bus, right? So the bus is stationary. So obviously, if the bus is stationary, right? You are also, let's say you are also stationary on that bus, all right? So if a bus, for example, starts to move, what will happen to you? I think you have noticed this, right? You start by moving backwards, right? Why are you moving backwards? It's because of your inertia. You are trying to resist a state of what? Of motion, all right? So that is another application actually of what? Of Newton first law, all right? Another one, for example, we are in a taxi, and I think you have noticed this, right? So we are in a taxi, for example, or it doesn't matter, even if it's a car, it's a bus, but as long as it's an object that is moving. So if you're in a taxi, for example, and I think you have noticed this, if a taxi is about to turn, a curve, right? So what happens to us, right? If it's about to turn, when it turns, we move forward, right? Or we move to the initial direction of what? Of the car, all right? We don't follow the curve, right? The reason why we don't follow a curve is because of our inertia. So we are trying to resist the state of motion to, okay, as passengers, we are moving to this direction, and the car now is changing the direction. So we are trying to resist the state of what? Of our motion. The reason being is because of our what? Our inertia. So this is the law of inertia, so you should understand what is inertia, all right? And then this is now the importance of what? Of seat belts. We are explaining that using what? Newton first law. So according to Newton first law, if you are not wearing a seat belt, we are likely to do what? To experience what? Injuries. Because, for example, if a car is moving at a speed of 100 kilometers per hour, for example, forward, if a car suddenly stops, what happens? You continue moving at that what speed in that direction, and obvious, if you are not wearing a seatbelt, that is going to hold you back, for example, then what is going to happen to you? You are likely to to collide with the steering wheel, the dashboard, even the windscreen. So I hope by now we understand the importance of wearing seat belts. So that is our Newton first law. Then our Newton second law. So Newton second law, the difference between the two is that when it comes to your Newton first law, right, the object is either at rest, stationary forces, or they're being at equilibrium, and then an object is also moving at a constant velocity. So there are two important things that you need to be careful about when it comes to your Newton's first law. It's either an object is at rest or an object is moving at a constant velocity. So if you are reading a statement, let's say now we are dealing with questions and you read a statement and they're saying this object is stationary, what should come to your mind is that this is application of of Newton's first law. If they're saying an object is moving at a constant speed or constant velocity, again, it's going to be application of Newton's first law. All right. So maybe let me go back and try to talk more about this. Right. This Newton's first law. Okay. So for Newton's first law, if an object is at rest, what is it that we need to know? F net acting on that object will be 0 newtons. If F net is equals to 0, then the acceleration is also going to be 0 meters per second per second squared, right? So when do we have this? If an object is at rest, so is rest or stationary, we are aware of that. If an object is moving at a constant velocity or speed. And also, if we are told that the forces acting on an object are at equilibrium, right? So if forces acting on an object, they're at equilibrium, or an object is at rest, an object is moving at a constant velocity, that is application of Newton's first law. And if it's application of Newton's first law, net force acting on that object will be equals to 0. By now we understand what is net force. We did talk about that last week. All right. So net force acting on an object is equals to 0 newtons if an object is at rest or stationary, moving at a constant velocity or speed. And if we are told that these forces are at equilibrium, we should know that the net force, the acceleration acting on that object is going to be 0. Right. So another thing, when they ask questions, they will say, okay, let's say, for example, we're given a statement and they're saying this object is moving at a constant velocity. And then they will say, write down the magnitude of the net force acting on this object. So if they say, write down the magnitude, you cannot just say, okay, it's 0. So we don't know whether it's 0 Weber, is 0 volts, but the issue of units is very, very important. To show us that we are talking about a force, to show us that we are talking about the acceleration, give us the correct SI units. Even if the magnitude is 0, right? Then make sure that you give the correct SI unit. So for Newton's first law, object is stationary, constant velocity, forces at equilibrium, F net is 0 newtons, and then acceleration of that object will be 0 meters per second squared. Then Newton's second law. So now when it comes to Newton's second law, it states that when a net force is applied on an object accelerates in the direction of the net force with an acceleration that is directly proportional to the net force and inversely proportional to the mass. Okay, so now there's a net force that is acting on an object. So previously, when it comes to your Newton's first law, what is the magnitude of the net force? Is 0 newtons. But so which means that here your net force, when it comes to your Newton's second law, your net force is now unequals to 0. Okay, it is unequals to 0. If your net force is unequals to 0, then even your acceleration is unequals to to 0. This is very, very important. Okay, so that is the difference between your Newton's first law and your Newton's second law. So Newton's first, F net is being 0 if an object is at rest, moving at a constant velocity, or if you are told that the forces that are acting on this object, they are at equilibrium. We already know if an object is stationary, an object is moving at a constant velocity, it means that the forces acting, they are balanced, right? So the forces are at at equilibrium. And if the forces are at equilibrium, it means that the net force acting on that object will be 0 newtons, right? So here there's a net force which is unequals to 0. It's either greater or less. Actually, it's unequals to unequals to 0. It's unlike when it comes to your Newton's first law. All right. So then if F net is unequals to 0, then your F net will be equals to MA, right? So that is your Newton's second law, right? So it states that when a net force is applied on an object with acceleration accelerates in the direction of the force with an acceleration that is directly proportional to the force and inversely proportional to the mass of an object, right? So if you read the statement and you see that there's change in velocity, right? If there's change in velocity, it means that that object is accelerating, sorry. But why am I saying that? Because remember, acceleration is the rate of change of what? Of velocity. So if there's change in velocity, it means that that object is what? Is accelerating. For example, let's say the initial velocity is 0 meters per second, the final is 5 meters per second. So there's change in what? In velocity. So it means that the object is what? Is accelerating, right? And or they will say this object accelerates, right? If they say the object accelerates, it means that this is going to be what? Now the application of what? Of Newton's second law. So for your Newton's first law, rest, object is being at rest or moving at a constant velocity. But for the Newton's second law, an object is accelerating. So if an object is accelerating, F net will be equals to what? Ma. So that will be the difference actually between your Newton's first law and your Newton's what? Second law. All right. So then again, we can look at again more closely to now the relationship between, you know, the net force and acceleration, the acceleration and what, and the mass, right? So according to Newton second law, acceleration is directly proportional to the force or the net force, right? And acceleration is inversely proportional to what? To the mass. All right. So that is the relationship between acceleration and the net force, and acceleration and what? And the mass. All right. So look at that graph. Okay. So this is the graph of acceleration versus the net force. So you can see that there is a direct proportionality according to the law itself. Ne? So remember, acceleration is directly proportional to what? To the force, right? And inversely proportional to what? To the mass. So you can see that here we are having two objects. So it's object M1 and object what? M2. All right. So you can see that there's a direct proportion for both graphs. There's a direct proportionality between acceleration and what? And the net force. So this is Newton what? Second law. So your dependent variable is acceleration, which is measured in meters per second squared, and then the force is your independent variable, which is measured in what? In newtons, right? So let's look at the relationship between the two, right? The relationship we can see is directly what? Proportional. So if we're talking about the direct, if the relationship is directly proportional, what is the meaning of that, right? So let me just give you two graphs, right? This is the graph. Let's say this is A versus what? Versus F, all right? So we are having another graph. We are having something like this, okay? So maybe this Y, and then here we can put what? We can put X, right? So between the two graphs, which graph shows a direct proportionality? Direct proportionality, right? Between the dependent and the independent what? Variable, right? So you can see for both graphs, right? As for example here, as F increases, what happens to A? A also increases. Same even here, as X increases, Y also increases. But with this one, there's no direct proportionality. Why am I saying there's no direct proportionality? Direct proportionality, your graph must start from the origin. Your straight line must start from what? From the origin. So with this one, it does not start from the origin. Although as this increases, your X increases, what happens to your Y also increases. But there's no direct proportionality between Y and what? And X. But here there's a direct proportionality between A and what? And F, because your straight line starts from what? Starts from the origin. So please be careful when it comes to that. If they're asking you about the relationship, don't just say because I can see as X increases, Y increases, then there's a direct proportionality between the two, you know, variables. Yes, between the two what? Variables. So when it comes to this one, there's no direct proportionality, although as this one increases, this one also increases, but there's no direct proportionality. Why am I saying there's no direct proportionality? You can see your graph does not start from what? From the origin. Okay, so now let's look at those two graphs representing the two masses, or the two objects of different masses, right? So there's a for both graphs, right? There's a direct proportionality between acceleration and what? And the force. So there's a direct proportionality between the two. So if they can ask you to give them, you know, the dependent, you will say it's acceleration. The independent, which is along your horizontal axis, it will be what? The force. and then the controlled what variable here. The controlled variable should be what? Should be the mass. Okay, so remember there's a direct proportionality between F and what? And A, or A and F at constant what? Mass, right? So according to this equation, F net equals to ma, right? Acceleration and the net force that are directly proportional, provided the mass of an object remains what? The same, right? And then again, F net, right? Not F net, but A. I'm making A the subject of the formula. It will be F net over what? Over m, right? Then your acceleration inversely proportional to mass at constant what? F net. So we cannot talk about the relationship between this and this if this is not constant. You cannot talk about the relationship between this and this, which is A and M, if F net is not what? Is not constant. So by now we know the relationship between A and F, between A and what? And M. Between A and F is directly proportional at constant mass, and then between what? A and mass is inversely proportional at constant what? Net force, right? So another thing that they can ask here, I said to you, one, the dependent variable is acceleration, independent, it's the force, right? The controlled would be the mass, and they will ask you the physical quantity that is represented by the gradient, all right? So this is a straight line, right? So if it's a straight line, we know that the gradient does not change, right? So how are you going to find the gradient of this graph, right? So now this is what you need to do, okay? You are having acceleration this side, all right? You are having force as on your horizontal axis, which is your independent what? Variable, right? So now what is it that you need to do? You want to find out, actually you want to find what the physical quantity that is represented by the gradient of this graph. Then you need to check an equation where we are having acceleration and the force, right? The equation where we are having acceleration and the force is F net equals to what? Ma, all right? So you can see there's net force, there's also what? The acceleration, all right? So then this is a straight line. You know the equation of a straight line. Y equals to what? Mx plus what? Plus c. So your y-intercept here, it's 0 because your graph starts from the origin, all right? So now we are having y equals to what here? Mx, because this is what? This is 0, right? Then what is it that you need to do? You need to arrange this equation, right? This one, or manipulate this equation in a form of y equals to what? Mx, making sure that your y it's what? It's a. Your y is a, right? Your y, you have y axis when it comes to maths, and then you're having your what here? X axis, and then your x it's what? It's f. Okay, so let's try to do that and see if we are going to win. Okay, let's try to do that. So I'm having F net equals to MA. This is the equation that I have, and this equation is there on the data sheet, right? So I'm making what here? I need to make, remember, y here is the subject of the formula. And what is y according to my graph? Is A. So I need to make A here the subject of the formula, right? So for me to make A the subject of the formula, it will be A equals to what here? F net over what? Over m. So I need to divide by m on both sides, all right? So then this will be A, right? So our x should be what? Our x should be what? Should be what? The net force, right? Our A, it's y, and then our x, I'm having what there? The net force. Okay? So it will be A equals to what? 1 over m times what? F net. Okay? This is y, this is m, this is x, right? You can see my y is acceleration, and that is correct. It should be acceleration, right? And then my x is what? Is the force or the net force. And then this is also what? Correct. And then m here is the gradient. Ne? So which means that the gradient of this graph represents what? The inverse of the mass. Not sure whether you got that. Ne? So you want to find out the physical quantity that is represented by the gradient of this graph. Okay? So first thing that you need to do, check your variables, your dependent, your independent. I'm having A as my dependent, I'm having F as my independent, right? So I need to check an equation now. Find an equation where I'm having what A and also what F net or F, right? That equation is F net equals what? MA, right? So if that equation is F net equals to MA, this is a straight line. You know the equation of a straight line? It's when it comes to your maths, it's y equals to what? Mx, right? What is your y? It should be what? A. And then what is your x? It should be what? F net. So you need to manipulate this equation, right? So that in a form of y equals to mx, right? Because your c is what? It's 0. So we did that. We said F net equals to what? MA. Then my y, because it's the subject of the formula when it comes to y equals to mx, right? My y is a. Okay, I've done that. I've made a the subject of the formula, right? Then equals to F net over m. But remember my F net should be what? X, right? So what I did here, I said, okay, for me to have F net as my x, I have to say y, not y, but a equals to 1 over m times what? F net. Because 1 over m times F net is still what? F net over m. So my m here will be 1 over m, or my gradient will be the inverse of the mass of that object, okay? Then my what x will be F net. So here, so the equation of both graphs is not F net, but it's A equals to what? 1 over m times what here? F net. Okay? Right? This is y equals to mx. My x is F net, my y is A. Then the gradient will be the inverse of what? Of the mass. Right? So between the two objects, what they can say, okay, which object? Is it object 1 or object 2 that has what? Greater mass? Okay? How are you going to find out? Right? First thing that you need to do, okay, already you know that the gradient represents the inverse of the mass. Okay? The gradient represents the inverse of what? Of the mass. Then the gradient of m1, right? I'm talking about the gradient. Ne? Let me write it in full. The gradient of m1, right, will be greater than the gradient of m2. I'm talking about the gradient, right, of the line. So which line is steeper than the other one? Is m1 compared to what? To your m2, all right? So the gradient of m1 is greater than the gradient of what? Of m2. This line is steeper than the one of m2. So if it's like that, then remember the gradient represents 1 over m. Okay? So which means that if the gradient, remember we are saying the gradient, I want to write this. Okay, let me write it here. I want to write this. So the gradient of m1 greater than the gradient of what? Of m2. But remember, gradient represents 1 over m. Okay? So if the gradient, let's say, for example, the gradient here is 2, right? Then the gradient of m2 is what? It's 1. So if I want to get the mass now, because the gradient, I want the mass now, right? So the gradient of m1 is 2, which is equals to 1 over m. So my m here will be 1 over 2 kilograms. Okay? The mass. That is for m1. m2. Gradient equals to 1 over m. What is the gradient of line m2? It's 1, right? Then this is equals to 1 over m. which means that mass would be what? 1 kilogram. Okay? Then it means that although the gradient of line M1 is greater than the gradient of line M2, but the mass of M1 will be less than, you can see that this is a M2, right? The mass of M1 will be less than the mass of what? Of M2. So these are some of the questions that they can ask. Okay, independent variable, dependent variable, give us the controlled, then talk about the relationship based on what you see on that graph. Then they also ask you about the physical quantity represented by the gradient of this graph, right? So the physical quantity represented by the gradient is the inverse of the mass, right? So the gradient of M1, of M2 is greater than the gradient of what? The gradient of what? Of M2 actually is less than, this is M2, is less than the gradient of what? Of M1. But the mass of M2 will be greater than the mass of what? Of M1, because gradient represents 1 over M, right? Gradient represents the inverse of what? Of the mass, right? Then Newton's first law and Newton's second law of motion, then the application, right? So already learners have talked about this, that when it comes to your Newton first, it's either an object is at rest or moving at a constant velocity or constant speed. I know when learners see the word constant, they think of Newton first law. Remember, it should be constant speed or constant what? Velocity, not constant force, right? So please be careful when it comes to that. Then when it comes to Newton's second law, an object is accelerating, right? So how do we solve problems when it comes to the application of Newton first and Newton second law? First thing that you need to do, make sure that you choose, the direction, right? Determine all the forces acting on an object, and then after finding all those forces acting on an object, make sure that you draw a correct free body diagram or correct force diagram. So first thing, choose direction. Okay, remember here you're dealing with vectors, and a vector, it's a physical quantity with both magnitude and direction. So make sure that you choose direction, and then from there identify all the forces. After identifying all the forces, draw a correct free body diagram or force diagram, and then again, if any forces are not parallel or perpendicular to the line of motion, resolve those vectors into their components. For example, if a force is applied at what? At an angle, something like this, you need to resolve this force into its what? The components, which is your vertical component, your Fy, and your horizontal what? Component, which is your Fx. Then on an inclined plane, make sure that you resolve your weight or the gravitational force into its what? Components. So those are the things that are very, very important here, right? And then from there, find the sum the sum of all perpendicular forces to the line of motion must be 0. So which means that this is very, very important, learners. Ne? So 1, we are saying to you, make sure that you choose the direction, all right? 2, identify all the forces. 3, draw a correct free body diagram. 4, what you need to understand, there are 3 planes that we are going to focus on here. According to our examination guideline, it's either horizontal plane, vertical plane, and inclined plane. So if it's horizontal plane, we are expecting that object to move horizontal, right? So which F net are you supposed to find? It will be the F net for the forces that are acting horizontal or the forces that are parallel to the surface, okay? Then the F net for the forces that are perpendicular or that are acting vertical to the surface, their net force will be what? Will be 0 newtons, right? Same on a vertical plane, right? It's vertical plane. The forces that we're going to focus on are forces that are acting vertical. So here are forces that are acting horizontal. Here are forces that are acting vertical. Here are forces, when it comes to an incline, there are forces that are acting parallel to the plane, okay? So that is the F net that you are supposed to focus on, right? Forces parallel to the plane, then the forces perpendicular to the plane, those forces, their net force will be what? 0 newtons. I hope you are following, right? So first thing, choose a direction. Second, identify all the forces. Third, make sure that you draw a correct free body diagram or what? Or force diagram. Fourth, check check the plane. Is it the horizontal plane or inclined plane? All right. Horizontal plane, focus on forces that are acting horizontal, right? Or forces that are parallel to that horizontal plane. Then the forces that are acting vertical, or forces that are perpendicular to that horizontal plane, their net force should be 0. On a vertical plane, focus on the forces that are acting vertical, all right? Then forces that are acting, sideways, for example, their net force should be 0 newtons, right? Then when it comes to an inclined plane, which forces are you supposed to focus on? Focus on the forces that are acting, parallel to the plane. And then the forces that are acting perpendicular to the plane, that net force should be what? 0 newtons. So that is very, very important. Again, the important thing that you must have, right, in your exercise book when you are dealing with physics or when you're dealing with mechanics, right, make sure that you have this. So fortunately, I know your teachers, they've given you both, the soft copies and the hard copies for the examination guidelines. So I know you have this on your examination guideline. So if it's there, your teacher is supposed actually to make copies, and you need to paste this on your exercise books. So you need to make sure that you paste it so that you familiarize yourself with this data sheet and how to use it. All right. So when it comes to physics, the nicest thing is that with physics, there's no need for you to memorize the equations. So the equations they will be given to you in a form of a data sheet like this one. Then what is it that you need to do? You need to know when to use this equation, right? And it's very nice. You can see the heading here is what? Is force. So when you're dealing with forces, so you need to focus on these equations when you're dealing with with problems, all right? So this is the equation, F net equals to MA. So we're not expecting learners to write F equals to MA. It should be F net, which is the sum of the forces equals to mass times what? Times acceleration. So this one, we did talk about this one last week when we were focusing on different kinds of forces, all right? So for example, when it comes to different types of frictions, your kinetic friction, your static friction, maximum static friction. So this is how we have to calculate the maximum static friction. This is how we have to calculate the kinetic friction. And again, let's not forget, learners, when it comes to these equations, we can even talk about the relationship between Fk and N at constant mu k, or F max, Fs max, and N at constant mu s, all right? So this is the equation that we use to calculate weight or gravitational force of an object, which is weight equals to mg. So we'll talk more about these ones next week when we're focusing now on Newton's law of universal gravitation. So let's look at the problems. So these are the problems that needs you to apply either Newton first or Newton second, all right? So the statement says a 5 kilogram box is pulled across a tabletop with is pulled across a tabletop with a force of 12 newtons. A frictional force of 5 newtons is present between the table and the box. Right, first question, they want us to draw a force diagram illustrating all the forces acting on that 5 kilogram block, and then from there calculate the acceleration of the box across the table. All right, then where are we supposed to start? Choose direction. Okay, so we are choosing direction. So which direction are we choosing? Okay, before we move on, which plane are we dealing with here? Is the horizontal plane. Okay, this is the horizontal plane. So you are having a force of applied force of 12 newtons and then the frictional force of 5 newtons. Okay, so you can see that these forces are not at equilibrium. Okay, so this object, like it or not, for this object, the net force that is acting here, the net force is going to be what? Unequals to 0. So if it's unequals to 0, what will happen to this object? This object is going to accelerate. Unless if here force applied was 12 and then the frictional force was going to be what? 12, acting in opposite directions. So we are going to say this object will remain stationary or it will continue moving. If it was moving it was going to move at a constant velocity. But in this case, you can see the horizontal forces, they're not balanced, right? So I'm having 12 this side, I'm having 5 this side. So like it or not, my F net won't be equals to 0, or it will be greater than 0. So which means that now it's no longer application of Newton first, but it will be application of Newton second law, because this object is accelerating. The F net is unequals to what? And unequals to 0. So they want us to draw a force diagram and the free body or a free body diagram to indicate all the forces acting on an object. All right. So how many forces, right? So by now we know how to draw free body diagrams. So the forces, I'm having the first one, which is always there in all the free body diagrams. When they say draw a free body diagram, you should know that FG is always there. Whether you are dealing with a horizontal plane, object on a vertical plane, object on an inclined plane, FG is always there and is always acting downward. So I'm having FG, I'm having normal force there, I'm having that force applied of 12 newtons and the frictional force of what? Of 5 newtons. So they want us to calculate the acceleration. So how are you going to calculate acceleration? Remember, this is application of which law? Newton's second law. Why am I saying that? Forces are not balanced. F net is unequals to 0, right? So there's a net force that is acting on this object. Right? This object is not stationary. This object is not moving at a constant velocity. So there's a net force that is acting on that object. Then we can also calculate the net force that is acting on that object. Okay? So I'm having F net. So I'm looking for F net here. Right? So how many forces am I having here? There are 2. Is the force applied? So I'll just write F there. Is the force applied? I'm also having what? Frictional force. But frictional force is acting in the opposite what? Opposite direction. So that is why it is going to be negative there, right? So this tells you about the direction. So in other words, I'm taking a right as positive here, or the direction of motion of this object as positive, right? So friction, it's going to be negative, right? F is 12 plus into minus the frictional force, which is what? 5. So I'm having 12 minus what? 12 minus 5, which is going to be what here? 7 newtons or plus 7 newtons. And that 7 newtons, if it's plus, remember which direction did you take as positive? The right. Ne? So it will be 7 newtons in which direction? To the right. So that is the net force. So you can see there's net force that is acting on this object, which means that this object is what? Is accelerating. Right. So then they want acceleration. I know F net is equals to what? MA, right? So what is my F net? Is 7, and then mass of this object is given. It's what? 5. Then I'm multiplying that by what? By acceleration. So my acceleration will be what? 7 divided by what? By 5. Okay? So which is equals to what? 1.4 meters per second squared. In which direction? To the right. Okay? Remember, this is positive. Okay? So another thing that you need to understand when it comes to this equation, F net and A, they are vectors, right? So if they are vectors, always we need to give what? The direction, unless if the question says find the magnitude. But if they say calculate acceleration, we are expecting magnitude and direction. Calculate force of net force, we are expecting magnitude and what? And direction. Unless if they're going to say calculate the magnitude of acceleration. So it's when now we are only looking for what? The magnitude, right? So your F net and A, they're always acting in the same what? Direction. According to the Newton's second law, when a net force is applied on an object or acts on an object will accelerate in the direction of what? Of the net force, right? So which means that the net force and acceleration, they're always acting in the same what? Direction. So the direction of the two is always the same. So you can't have right here for the net force and you have left for the acceleration. So it's impossible when it comes to Newton's second law, right? Then you can see now the object here, example 2, a force actually is applied at an angle. Remember, when you are dealing with problems under your Newton first and your Newton second, or application of Newton first and Newton second, right? Make sure you choose direction, identify all the forces, right? And if there's a force that is applied at an angle like this one, you resolve that force into its what? Components. Ne? Then draw a free body diagram, then you deal with what? With the calculations there. So you can see here they've done that. So you have your what here? Let's draw the free body diagram. I'm having the FG there, and then I'm having what? The normal force. So the normal force, and then there's that force which is applied at an angle. And then do you have friction here? So a 200 box is dragged across a level concrete floor, and then you are given the coefficient of kinetic friction. So this object is in motion since you are given the coefficient of kinetic friction. All right. Then, which means that there's frictional force here with a force of 700 newtons. So this force is 700 newtons. Okay. The force is 700 newtons. Then the rope attached to the box makes an angle of 35 with the horizontal. So this angle, Lenas, is 35, not 30, but 35. 35. So here is 35 degrees with the horizontal. All right. So then draw a free body diagram of all the forces. So the forces, it's normal force, Fg, your F, and your what? Sorry about that, your frictional force, right? Your Fk there. So these are the forces. It's 1, 2, 3, 4. So this is the free body diagram that we're expecting. But for you to be able to do your Roman figure 2 correctly, calculating the net force on the box, you need to make sure now, after drawing this correct free body diagram, what is it that you need to do? For you to answer this question or to do this calculation, this force is applied at an angle, right? So resolve that force into its components. So they've done that here. So the red force or component is your Fy there, and then this is going to be what? Your Fx. So you resolve that force into its what? Components. So that you'll see all the vertical forces and all the horizontal what? Forces. But since this object is moving horizontal or is on the horizontal plane, forces that are perpendicular to that horizontal plane, their net force is equal to what? 0. So I hope you are aware of all that, right? So how many forces that are horizontal? Is this Fx and this frictional force? Okay. Then they want us to draw a free body diagram. We have done that. Okay. Calculate the net force on the box. So now when it comes to calculation, the force is applied at an angle, resolve that force into its components so that you'll be able to see all the vertical forces, vertical components, and also horizontal components and or horizontal what? Forces, right? So I'm having as my F net, I'm having what? Fx minus what here? Plus or minus what? Fk. So remember, it's the sum. That is why I'm putting that a positive sign there. F net is the sum of all the forces. That is why I'm putting that positive sign there. But this becomes negative because it's acting in the opposite what direction. I'm taking the original direction of motion as positive. So my friction. So friction always negative for me, right? So you can do the same. So if there's friction, just make friction to be what? To be negative. Okay. Because always it opposes what? The motion. Right. Then what is my Fx? How do I calculate Fx? Fx is given by F what? Cos theta plus into minus what? Fk. Am I giving the magnitude of Fk? No, I'm not giving the magnitude of Fk, but I'm giving the coefficient of Fk, right? Or of kinetic what? Friction. Then how do I calculate Fk if I'm giving the coefficient? Go back to your data sheet, right? So my Fk is given by what? Mu k what? N. So where there is Fk, I can substitute by what? Mu k what? Mu k n. Then another thing which is very, very important here. How do I calculate my what? My normal force, right? So this is equal to F, which is 700, right? Cos what? 35. Minus, what is my mu k? I'm giving mu k there. I'm giving mu k there, right? So the mu k coefficient is 0.34. Okay, 0.34. So it's 0.34, my mu k, right? So I will substitute by 0.34 here. So let's check here. This is Roman figure 2, Fx and F, right? So my Fx, this is the magnitude of Fx, and then this is going to be the magnitude of what? Of Fk. How did they get this Fk? Check. Remember, your Fk is given by mu k n, but my n here is what? How many forces are acting perpendicular to the surface? There are 3. It's normal force, Fy, and Fg, right? So my normal force here will be Fg minus what? Fy, right? So they've done that here. Then my Fg, what? Mu k Fg minus Fy is 529.89. Then my F net will be 43.52. Okay? So, but what is important, a force is applied at an angle, resolve that force into its components so that you will see all the horizontal and all the vertical what? The vertical forces. Right, then they also want us to calculate the acceleration. So again, it's application of Newton's second law. Sorry about that. So then the equation is F net equals to MA. Already I have F net, which is 43.52, and then 43.52, and then what is my M here is 200, so it will be F net equals to MA. Then my F net will be what? 43.52, and then my M will be 200. Then A will be what? 43.52 divided by 200, which is going to be what? 0.22 meters per second squared in the original direction of what? Of motion, right? So there's a lot of work that we're supposed to do here. Since the force is applied at an angle, very, very important, learners. Make sure, one, choose direction, identify all the forces, draw a free body diagram. Then from there, when it comes to now calculations, if there's a force that is applied at an angle, resolve that force into its what? Components, right? It's the horizontal plane, the forces that, it's only the forces that are acting horizontal that will give F net that is greater than 0, right? But the forces that are acting perpendicular to what? To the horizontal, that horizontal plane, then their F net should be what? Should be 0. That is how we got our N equals to what? F what? G minus what? Fy. Remember, this thing is from what? F net equals to 0 for vertical forces. Your vertical forces, it's what? Your normal force plus your what? Your Fy. This should, okay, plus your Fy minus your Fg, since it is acting in the opposite direction. This is equals to what? 0. So if you want to make N the subject of the formula, at the end we are going to have something like this. That is why here, when it comes to N, I substituted by Fg minus what? Fy, right? So let's look at this one also. So these are two body systems. So if it's two body systems, try to, make sure that you draw a free body diagram for each object in that system. All right, so the two objects is the 1,500 kilogram and the 6,000. So what are you supposed to do? Draw a free body diagram for both. A truck of mass 6,000 kilograms pulls a trailer which is 1,500 kilograms with a force of 9,450 newtons. Then they want us to calculate the acceleration of this truck and the tension in the tow bar joining truck and trailer. Ignore what? Friction. Okay, so they want us to ignore what? Friction. So how many forces now? First thing, the object is moving to that direction, or the system is moving to that direction, right? So they said we should ignore what? Ignore friction. So let's draw a free body diagram. Before that, we are drawing a free body diagram for 1,500. So the forces, it's the normal force is the Fg, there is tension, right? So there's no friction. So there are three forces here. Then when it comes to the 6,001, so there's a force that is applied, which is what? Applied. This is 9,450. There's normal force, there's Fg. Remember, there's no friction, which opposes what? The motion. So, then there's also what? Tension. So for a 1,500 kilogram, there are three forces, right? And then for a 6,000 kilogram, there are 1, 2, 3, 4 forces, okay? So this way you have to start identifying all the forces and making sure that you draw a correct free body what? Diagram. Then from here they want us to calculate acceleration and also what? The tension. How are you going to calculate acceleration and the tension? Right. First thing that you need to do, right? Remember, they're looking for what? For tension. Focus on each object, because if you focus on both objects in a system, right, we are going to lose marks, right? So we are having these two objects. Normal force, Fg, tension, right? Normal force, Fg, force applied, and tension, right? Remember, this force and this one, they're equal in magnitude, acting in opposite what? Directions. So if you are going to say F net, I want to show you something. If you are going to say F net equals to, you are only focusing on the horizontal forces, ne? So how many are they? These are the horizontal what? Forces, ne? So you'll say F net equals to, we are taking the original direction of motion as positive, which is to the right as positive. So it will be what? I'm starting with this one. Let's start with, yeah, it's fine. We can start with this one. Is tension, right? minus tension, which is this one, because it's acting in the opposite direction, plus what? Plus F, right? Okay, then it means that your F net actually is equals to what? Is equals to F, ne? So we don't want you to use, we are not saying this is incorrect, ne? But we don't want you to use this, because if you do this, you are going to lose marks, all right? So what is it that you need to do? You treat each object separate, ne? So now I'm going to start with what? With this one, right? So since this object is accelerating, right? F net, I'm dealing with what? 1,500 is equals to what? MA, right? How many forces that are acting horizontal? It's only tension. This is equals to what? MA. This is my equation what? 1. Because there's nothing, before that, I'm giving the mass. So it's tension equals to, what is the mass? 1,000 what? 500 A. So this is the equation 1. Then you come to this one. This is what we want you to do, right? So don't combine all the forces in the system. Focus on each object. Have F net equals to MA for each object, all right? So for your 1,500 kilogram, this is the equation. It's T equals to 15,000, 1,500 or 1,500 A. And then for this one, there are only two, right? So there are two horizontal forces is T and F. All right. So for the 1,500 kilogram, so I'm also having what here? 6,000 kilogram object. Ne? So for that, for 1,500, I'm having T equals to 1,500 A. And then for this one, it will be F net equals to what? MA. Then is F minus T equals to MA. And then F, let's check what is the magnitude of F. This is the magnitude of F, which is, let's go back, 9,450. So it's 9,450 minus T equals to what? The mass is 6,000. It will be 6,000 A, because I have to multiply that by A, right? So what I can do here, because I want to find the magnitude of A. So for me to get the magnitude of A, I need to eliminate T, right? So how am I going to eliminate T? So I can do this. This side I'm having T equals to 1,500 A, ne? So let me make T the subject of the formula here. So it will be what here? 9,450 minus 6,000 A. This is equals to what? T, right? So this, I can say this is T1, this is what? T2. So I can equate the two equations. T1 equals to what here? T2. So what is my T1? It's 1,500 A, and then my T2 is 9,450 minus 6,000 A, right? So combine the two, you can have what here? 1,500 A plus, because it's negative there, 6,000 A equals to what? This side, this is already this side, is 9,450, 450. And then what is, this is 1,500 plus 6,000, which is going to be what? 7,000, 500, ne? And then this is equals to 9,450 divided by 7,500 divided by 7,000 what? 500. Then we'll get the magnitude of what? Of A. So this is the magnitude of A that they got, which is 1.26, ne? So it's 1.26 meters per second squared in the original direction of motion, or in this case will be what? To the right. Okay, so that is how we can find what? The acceleration there. Then after getting the acceleration, we can find tension. Tension is equals to 1,000. I'm taking equation 1 there. It's equals to 1,500 A. Then it will be 1,500 multiplied by A, which is going to be what? 1.26. Then we'll get our answer in newtons. And what they got here, it's 1890, which is 1,800 and what? And 90. 1,800 and what? And 90 newtons. Right. So again, here it was application of Newton what? Second law. Right. So please be careful, learners. Don't combine, both what don't combine the forces for both objects, right? If you are going to do that, we are not saying it's wrong, but you are going to lose marks. Rather, or what is it that we want you to do is to make sure that you focus on on each object. All right. Then another example here. So you can see it's two body system. You have an 800 there and the 500 which is hanged. So it's horizontal plane versus the vertical plane. An 80 kilogram block rests on a rough horizontal table. So immediately when they say rough, it means that here there's frictional force. All right. So on a rough horizontal table and is connected by a light inextensible string passing over a frictionless pulley to a 5 kilogram mass hanging vertically. A 75 Newton force is applied to the 8 kilogram block, making an angle of 30 with the horizontal, causing the block to slide to the left. All right. So the direction of motion is to the left. Okay. Then we are given the coefficient of friction between the 8 kilogram block and the surface, which is 0.25. Then they want us to draw a free body diagram, right? So free body diagram for 8 kilogram. So the free body diagram for the 8 kilogram, it will be the FG there. You have your your normal force, force applied, and also which is that 75 newtons. And then it's a rough surface. We are told that it slides to the left, which means that the frictional force will act in which direction? To the right. So this is the free body diagram. And for a 5 kilogram, there are only two forces. It's the FG there and the tension, which means that even here we should have tension here because there's a cable there or a string. So there's also the tension. So these are the free body diagrams for both objects. So they wanted you to draw for only one object, but you need both, especially when it comes to the calculations, right? They want us to calculate now the normal force acting on that 8 kilogram block. Ne? So because there's no normal force here, you've seen that. For the 5 kilogram block, there's no normal force, okay? So they want the normal force that is acting on on the 8 kilogram block. So what is it that you need to do now? You resolve this force into its components. So after resolving, you will have your your Fy acting upwards, and then there is there, your normal force there, and also your Fx, your Fg, and also the frictional force. So vertical forces, there are 3, all right? So vertical forces, there are 3, okay? So if vertical forces are 3, you will have your normal force plus your Fy equals to, not equals to, let's do this, plus your Fy, okay, minus Fg equals to 0. We are aware of this because this is the horizontal plane. The 8 kilogram block is on the horizontal plane. So on the horizontal plane, the forces that are perpendicular to the horizontal plane, their net force will be 0 newtons, right? So your normal force will be Fg minus Fy, which is mg, this one, and then Fy is F sine theta. So the mass is 8 times 9.8 minus F, which is 75, all right? Which is 75 sine what? What is the angle? The angle is 30, so sine 30 degrees. Okay, so this is how we are going to find our our normal force. Okay, so this is the magnitude of of the normal force. So it's going to be Fg minus Fy. So this is the magnitude of of the normal force. Then they want us to calculate the tension. So the tension, already we are given we have resolved that force into its components. So they want the tension. Okay, so how are we going to get the tension? Let's remember, I said to you, since there are 2 objects here, focus on each object. Ne? So we can start with we can start with the 8 kilogram, right? The 8 kilogram F net equals to MA. So forces that are acting horizontal, ne? This is your Fx, right? There's tension, friction, and and Fx. And I'm taking the direction of motion as positive, which is to the left as what? As positive. So it will be what here? Fx minus what? Fk minus tension equals to what? Ma. I'm taking the direction of motion which is to the left as what? As positive, right? So I need to do this. So it will be what here? It will be F cos, because now I'm dealing with the horizontal what now? Component. Ne? So it will be F cos theta minus, am I giving Fk? I know that the surface is rough, but I'm giving what? The coefficient of kinetic friction, all right? So it will be what here? Minus mu k n, right? Minus tension equals to what? Ma, all right? So my F is 75 cos what? 30 degrees minus 0.25. Already I've calculated the magnitude of the normal force, which is 40.9 minus tension equals to what is the mass is 8 times what? The acceleration, and I don't have the magnitude of what? Of the acceleration. So that will be my equation what? Equation 1. All right? Let me add a page. Okay? Right. So here I'm having what? 75 cos 30 minus t minus mu kn equals to what? 8a, which is going to be 64.95. That is 75 cos 30. Then what? 0.25 times 40 equals to 8a. So my equation 1 will be this one, right? So let's move to what now? The 5 kilogram, right? So the 5 kilogram F net equals to ma. That is the 5 kilogram now. Okay, so F net equals to ma. How many forces are acting there? There are 2. Okay, so if there are 2, remember I'm taking left as positive. So this system is moving to that direction. So if it's moving to that direction, so which means that even the object, the 5 kilogram, will move up, right? So up will be positive, and then this one will be what? Negative. So it's T minus what? Fg equals to what? Ma. So there are only 2 forces there. It's tension and what? And Fg. Okay? So T minus mg equals to what? Ma. So it's T minus what? M, it's 5 times what? 9.8. And then this is 5a what? 5a. Then that is your equation number what? 2. Then from there, what is it that you need to do? Is to eliminate, because they're looking for tension, so you can eliminate what? What is this? You can eliminate what? Tension. So how are you going to eliminate tension? So this is how you can eliminate tension. So you have your what? For your first object. So let's do this. So I'm having what? For the 5 kilogram, I'm having this. Okay? So, and then for the other one, I'm having 54.7 minus t equals to 8a. So it's 54 point what? 0.73, ne? Minus t equals to what? 8a. So this is your equation 1. So what can you do here to eliminate t? Not eliminate t, but they're looking for what here? Let's check the question. Calculate the tension. So eliminate a, right? Or some learners, what they can do, they can start by finding a, and then after finding a, you can calculate what? The tension. But let's just go straight to the point, because we are looking for what here? For tension, we need to eliminate what? A. So how can we eliminate a? You can see that here I'm having what? I'm having 5, and then here I'm having what? I'm having 8, right? So for me to be able to eliminate this, I cannot say this minus that, okay? So what is it that I need to do here is to make sure that the acceleration is equal in both equations. How am I going to do that? Multiply this one by 8 and multiply this one by what? By 5. So if here I was having 2, then here I was having 3. I was going to multiply that by 3 and then multiply this one by what? By 2. Okay, so, and when I multiply, I'm not only multiplying what? 5a, but I'm multiplying everything in the equation. So which means that for this equation, I'm going to have what? 8t minus, what is 5? 5 times 9.8 is 49. I'm multiplying that by what now? By 8. So it's 300 and what? And 92. Okay? Equals to, what is 5 times 8? 5 times 8 equals to what? 40. So I'm having 40 what? 40A. Okay? Then this one I'm multiplying it by 5, right? So it's 5, multiply that by what? 54.73. Okay? The answer is 273.65 minus 392. Not 392. Oh, we are focusing on this one now, right? So I said 5 times that, and then 5 times t is minus what? Minus there's some, oh, minus 5t, because I'm multiplying everything by 5, equals to what? 40a. 40a. So you can see that equation 1, both equations that equals to 40a, right? So I can just equate the two, okay, or subtract equation 1 to equation 2. So it's up to you, right? So let me add another page. Okay, so let's go back. What am I having here? I'm having 8t minus 392. 8t minus 392 equals to 40a, right? And then the second one, I'm having 273.65. 273.65 minus 5t equals to 40a. So both equations that equals to 40a. So I can equate the two, right? So it's 8t minus 392 equals to 273.65 minus 5t. Then solve for t, it will be 5, it should be 8t plus 5t equals to 273.65 minus, not minus, but plus 392. So what is 5t plus 8t is 13t equals to 273.65 plus 392. Okay, so what am I having there is 665.65. Then you divide that by 13, divide that by 13. So your answer will be 51.20 watt newtons, right? So I'm not saying if you are going to find A first, right? The question says find tension. So for us to get tension, eliminate A. You have seen how I've eliminated what? A, to get tension. But some learners, what they can do, which is also acceptable, you can start by calculating what? Acceleration. After getting acceleration, then you substitute in one of the equations, and then you get what? The tension. All right. Then you can see they got also 51. We also got 51 with by eliminating what? By eliminating T. So what they did here, you can see that what they did here, yes, they started by finding what? Acceleration, and then from there calculate what tension. So this is another equation. So another activity. So those were examples. So now this is an activity. So which means that learners must also try to do it. So you have a block of 8.5 kilogram. A block of 8.5 kilogram is at equilibrium. So this is very, very important. At equilibrium, already we know F net equals to what? 0 Newton. So it's application of which law here? Is application of Newton what? First law. On an inclined plane as shown below, calculate the magnitude of the tension in the cord. Okay? The magnitude of the tension in the cord. So first thing first, we draw a free body diagram. This is an incline. Okay? So free body diagram, 1, I will have my what? My FG. Then I will have the normal force. And then there is what here? Tension. Okay, so a block of 5 kilogram is at equilibrium on an inclined plane as shown below. So these are the forces that are acting on what? On an object. So they want the magnitude of tension. Okay, how are we going to find the magnitude of tension? First thing, this is an inclined plane, right? So this is the free body diagram is correct. But now that when they're talking about calculations, we need to resolve weight into its what? Component. So let's resolve weight into its what? Components. So weight into its component. Let me insert a blank page. So we are resolving weight into its components. So I'm having what? Fg perpendicular. I'm having Fg what? There, parallel. And then there's normal force there. There's that tension. Okay? So already we are told that this object is at equilibrium, right? So O is stationary or is at equilibrium. F net is equal to 0. So here, so when I add tension and Fg, so tension minus Fg, what parallel, I must get what? 0. F net is equal to 0. Understand why F net is 0? Because we are told that this is at what? At equilibrium, right? Okay. Then tension, how do we calculate Fg parallel? It is given by what? Mg sine what? Sine theta, okay? Which is equals to 0. So tension minus M, it's what? What is M? It's 8.5 times 9.8 sine the angle of inclination, which is what? Which is 30. This is equals to what? 0. So which means that your tension will be equals to what? Tension will be equals to what? Transpose this, it will be 8 times 9.8 sine what? Sine 30 degrees. So the magnitude of tension, what is the magnitude of tension? The magnitude of tension is 41.65 newtons. Okay, 41.65 what newtons. So it's 41.65 what newtons. So please be careful. Know which law is this, is application of which law. So you can see we are told that this is at equilibrium. So make sure that you understand the meaning of that. Okay, which law to apply. All right. Then let's go back. The magnitude of the normal force. In this case, we have resolved your weight into its components. So how many perpendicular forces? There are 2. But since this object is not moving perpendicular, it's moving parallel to what? To it's so actually it's parallel to what? To the incline. So this and this you must get 0. But even for this 2, it's 0 because the forces are at what? Are at equilibrium. So net force equals to what? 0. Then you have normal force minus Fg perpendicular equals to 0, which means that actually your normal force will be equals to Fg what? Perpendicular, which is given by Mg cos what? Cos theta, which is going to be what here? It's 8 point what here? I think it's 8.5, not just 8. So here 8.5, even here 8.1.5. So it's 8.5 times 9.8 cos what? Cos 30 degrees. Then we'll get the magnitude of the normal force, which is what here? What did they get here? Which is 72.14. 72.14. So that is the normal force. And then from here, what are they looking for? They are looking for what? The magnitude of the block's acceleration if the cord is cut. So now the cord is cut. So if this cord is cut, it means that you are no longer having what? You are no longer having what? The tension. Okay? So if you are no longer having the tension, the forces, it will be your Fg parallel, and then your normal force there, and then this is cut, and then you have your Fg what here perpendicular, because we need to use this one where you have resolved for the calculations. Ne? So they want the acceleration. So F net, we know it's given by what? Ma, because now it's accelerating. So we are changing from Newton first to what? To Newton second, right? How many forces that are acting parallel? Since this object is moving parallel, is only one, which is our Fg parallel. This is equal to what? Ma, which is what here? Mg sine what? Theta equals to the mass times what? Acceleration, which is 8.5 times 9.8 sine the angle of inclination, which is 30 degrees, equals to 8.5. Multiply that by A, which is what we are looking for. Then we just divide this by 8.5, divide this by 8.5. Then you'll get the magnitude of what? of acceleration in meters per second squared. Obviously, this object is accelerating in which direction? Downwards. So this is the only force acting downwards there. So it's 8, which is going to be what here? Let's check what they got. So it's 4.9. So this is 4.9 meters per second squared. Okay. So I think we have seen when it comes to this problems, we are dealing with what? Application of Newton first, application of Newton second. So you must know when to use Newton first law, when to use Newton second law. Newton first, object is at rest, object being at equilibrium or stationary, or object moving at a constant velocity. It's when we are going to say F net is equal to 0. But when are we going to say F net equals to ma if an object is is accelerating, right? So another one, so it's two-body systems. Again, it's a two-body system. So a pulley is frictionless. The string of the negligible mass. Block 1 has a mass of 200 grams and block 2 50 grams. First thing that you need to do, you change this to kilograms, because mass should be in what? In kilograms. Which is, you can say this is 0.2 kilograms. And then this one will be 0.05 kilograms. So these are the things that you need to be careful about. So you draw a free body diagram, and then for both objects, so the free body diagram, you can see these are the free body diagrams for M1 and then also for what? For M2. So these are the free body diagrams. And then second question, calculate the magnitude of the system's acceleration. Please, learners, be careful when it comes to this problem. Yeah? Let's check your free body diagram. You can see the tension is acting up. Even here, the tension is acting up. So please be careful when you write the equations, because we said to you, you need to treat each object separate. So you must have equations or equation for each object, right? So the equation, for example, for this one, right? It's F net, okay, equals to MA. So here, let's say you decide to take what up as positive. So it will be tension minus Fg equals to what? MA. For the other one, F net equals to what? MA. So if you took up here as positive, there's no way that you'll take up as positive here, because in both equations, your tension will be positive, right? So we don't expect that. Tension should be in one object, it should be negative. In another object, it should be what? Positive, because tension acting in opposite directions, but the magnitude is the same, right? So, which means that here, I'm forced to take up as negative. So it would be what here? Fg minus tension equals to what here? Ma. This is very, very important, learners. This. See this, my T here is positive, but T here should be what? Should be negative. So please be careful. Although when it comes to the drawing of the free body diagrams, tension is acting up. So if you are taking up as positive, it means that you need to, for this one, this is an exception. So it's a different scenario, this one. So for this one, it's like you're choosing direction twice. And remember, we are not allowed to do that. Ne? So when you look at the your free body diagram, right? So this is acting up, this is also acting up. So if up here is positive, your up here should be what? Negative. To make sure that the tension is the same in magnitude but acting in opposite what? Direction. So please be careful. If you don't do that, let's say this is positive, at the end your acceleration will be 9.8. All right? So and it shouldn't be what? 9.8. So it should be 9.8 if you took up for both what free body diagrams as positive. Ne? So, but in this case, you can see your tension is positive here. Here it's what is negative. So it's what you need to do when you get a scenario like this one. So here, this is what they did. So first thing, they said draw a free body diagram, and then they wanted you to calculate what the acceleration. So you can see for M1, look at the tension is negative, and then for M2 is positive. So you have to be careful about that. And also the issue of conversion, making sure that the mass is in kilograms, not in grams. So you can see they did that. Ne? So equation 1, equation 2, and then the final answer here, it was what? 5.88 meters per second squared, which is the acceleration. Right. Then These are other questions. What calculate the magnitude of the tension? How are we going to calculate the magnitude of the tension? Already we have the magnitude of acceleration in equation B, and then for you to get the magnitude of tension, just substitute the magnitude of acceleration in one of the equations, right? Then you'll get what the tension, okay, in that system. Compare the net force of each block, state in which direction the pulley will rotate. So you are comparing the net force of each block, okay? So, and then from there, state in which direction will the system move. Is it going to move clockwise or anti-clockwise? Is what they wanted you to do. So the net force for all right, so for the first one, this is what the tension, okay, not the tension but the net force of what, of the 0.05, okay, and then the net force of another one, and then from there you compare the one with greater net force. In this case, let's check which one has a greater net force here. All right. So this is the tension. Okay, so here it was tension. I'm sorry. So this here it was tension. You can take any equation and then you substitute the value of A in any of the equations. So the tension was this, right? Then now we need to compare the net force. Okay. The net force, check what they've done here. We want to compare the net force. So the net force in this case will depend on the mass, right? It will depend on the mass because F net is equal to what? MA, right? So why am I saying it will depend on the mass? The acceleration, the system is the system that accelerated that, what is the acceleration here? The acceleration that we got is 5.88, ne? So the system accelerated 5.88. So in other words, your acceleration is constant. So how are you going to get the net force now? So we are looking at what? Net force versus mass, right? So the net force of the 0.2 kilogram will be greater than the net force of what? Of the 0.05 kilogram. Why am I saying that? At constant A, these two, they are directly what? Proportional. So the net force, I hope you understand that, ne? So I hope it does make sense. What is constant here? It's acceleration, which is 5.88, ne? So the net force of the 0.2 will be greater than the net force of the 0.05. So check, this is the net force of the 0.2, 1.176. This is the net force of the 0.05. It's 0.2. That is why I'm saying the net force of the 0.2 will be greater than the net force acting on what? On the 0.05. So they wanted us to do what? To compare. Then in that way, the pulley will turn anti-clockwise. Why are they saying it will turn anti-clockwise? Let's go back. We said the net force of, let's go back, the net force of the 0.2. Okay, let's check which one is the 0.2. The 0.2 block 1, it's 0.2, right? Block 2, 0.05, right? We are saying the net force of this will be greater than the net force acting on 0.05, right? So if it's like that, net force on this side will be greater than the net force acting on 0.05, which means that the pulley will rotate in this direction. It will follow M1, since the net force in M1 is greater than the net force in what? In M2. Where are we getting that from? We are getting that from what? From the equation F net equals to MA. A is constant, is for the system. If A is constant, then let's check the net force on each object. The net force now will depend on the mass, right? So by looking at that equation, if A is constant, F net and M, they're directly what? Proportional. So which means that the one with greater mass, obviously it will have what? Greater net force. In this case is the 0.2. So the net force acting on 0.2 will be greater than the net force acting on what? On the 0.05 kilograms. So that is why the system will rotate anti-clockwise. Right. So I think we have done justice when it comes to the application of Newton first and also Newton what? Second law. So next week we are going to look at more problems on what? On Newton second law. Thank you so much for watching this lesson. I believe or I hope we have gained a lot, especially the grade 11s, because this topic is new to you. All right. Thank you so much.